Hello everyone, welcome back. We are doing the second lesson on tension in cables, strength of materials and structures N6. And today I want us to look at a question from the question paper that was written on the 17th of April 2024. Is question number 2 and it reads as follows. A cable with a weight of 12 Newton per meter is suspended between two supports with a difference in height of 5 meters. The minimum tension in the cable is 216 Newton and the maximum slope of the cable is 46 degrees. Note, no marks will be given for using suspension bridge formulas. You do not have to worry about that part for now because they are talking about the second part of tension in cables and we haven't gotten to that part. So we do not know those formulas for now. All the formulas we've done so far, they are applicable to this question. We are given the Newton per meter, which is the small letter W. We are also given the minimum tension in the cable, we're given the maximum slope, and we're told about the height difference. We go to the questions. They say calculate the following: the maximum tension in the cable, and then the second question they say the length of the cable. The last question they say the horizontal distance between the supports. This is the diagram that I get according to what they are explaining to us. They are telling us that we have two supports, A and B, and there is a height difference between the two of 5 meters. That tells us that the two supports are not of the same height. We are given the small letter W, which is 12 Newton per meter. We are also given the minimum tension in the cable, and you know that the minimum tension in the cable is FH, which is 216 newtons. This is newtons. And we know that FH is the same throughout the cable. So it's going to be the same this side and this side. We have two diagrams like this because remember, we said whenever we are doing calculations, we are going to divide the cable at the turning point and take each side separately whenever we're doing calculations. And now we have to draw both the triangles because we are not dealing with two supports of equal height. Therefore, it is very important to have a diagram of this side and the diagram of this side. We were told about a slope. They said it's the maximum slope of the cable, which is 46 degrees. It is going to be on the side where we have the highest support. And also the maximum tension, which is the first question that they asked, is going to occur on the side which has the highest support, because we know this will be question number 1. FT, they say max. I'm saying it is equals to FT A because we know it is controlled by the Y value. It is given by Y times W, which is the small letter W. So this value is not going to change whether you are calculating for FT on support number B or FT on support number A. This is the only thing that is going to change, and the higher this value, the higher the FT is going to be. And you can tell that between A and B, the highest value of Y will be found on the support, which is support number A. Therefore, this one will be YA. The maximum tension will always be found at the support, and that will be the support which is the highest support. We have small letter W. We do not have the value of YA, but we can tell from the diagram that YA is equals to YO plus H plus D. We can get this since we have FH. We have this, which is H. Our problem is going to be this one. So for now, I'm going to use another formula to calculate for the value of YA, which is YA is equals to the length of the cable on the A side, which is from the turning point to the top of support number A squared, plus YO squared. We said we can get this value. Let's start by calculating for it. FH is equals to YO W. YO is equals to FH divided by W, small letter w, which will give us something like this. Small letter w, they said is 12, giving us the value of YO as 18 meters. So we already have this now. It's time to calculate for this one. I'm going to write our YO here. It's equals to 18 meters. Erase all of this. We are looking for LA, which is the length of the cable from the turning point to the top of support number A. We can find LA from the weight, which is the total weight A, which is given by W times LA. We have this, we do not have this. So first let's calculate for this. We can use trig ratios from this triangle. We can use tan theta, which is going to say the opposite divided by the adjacent. WA is equals to 216 times tan 46, which is equals to 223.675 newtons. And then you take this value, we come back to this equation. The value of LA will be 223.675 divided by 12, which is going to give me 18.64 meters. I'm going to put it here. LA is 18.64 meters, and then erase. Remember, we are trying to calculate for YA, and the formula is LA squared plus YO squared. We said LA is 18.64 squared plus 18, which is YO squared, and this is going to give me 25.912 meters. And then from here we can take this and put it here, where our FT max is going to be 25.912 times 12. That will give me 310.944 newtons. This is our answer for number 1. I am going to put it here. It's 310.944 newtons. Now, I know most of you might be wondering, why didn't we use trig ratios to get these values? Since we were able to use trig ratios to get this WA for us to be able to get LA, why didn't we just use the trig ratios and say cos theta it's equals to adjacent over hypotenuse, where we are going to have something like this. This is A. It's equals to 216 divided by cos 46. Yes, this is going to give us the same answer. The problem with this answer is that they are only going to give you 1 mark here because of the people who said these question papers. I don't know what is it that they are smoking, because they gave us everything for us to be able to get the answer in this way. So if you do not pay attention to the mark allocation, it's possible to fall into this trap, because it is quite obvious that the answer, the shortest way to get the answer is going to be this. But according to the mark allocation, they said 4 marks. So they are going to mark this answer. Remember, we calculated for this answer. They are going also to mark for this answer, the final answer as well. I'm not sure which one are they going to mark for as well, but this is also correct. But because of the mark allocation, we have to do the long process so that we get the full amount of marks that is allocated for this question. But either way, we are going to the second question, which is question number 2. They say calculate the length of the cable. We already have the length of the cable from the turning point to support number A. We now need the length of the cable from the turning point to support number B. Question number 2. The length of the cable is equals to the length of the cable from turning point to A plus the length of the cable from turning point to B. The length of the cable from turning point to A, we already got that it is 18.64 meters. And now from turning point to B, we can use this formula again. YB squared is equals to LB, which is what we are looking for, plus YO squared. This is what we are looking for, so we are going to make it the subject of the formula, getting our formula like this: YB squared minus YO squared. Now we already calculated for YO, but what is the value of YB? We already have the value of YA, and the difference between these two supports is the height, which is 5 meters. So our YB, we can say it is equals to, I did not write the value of YA down, but we calculated and then we got that it is equals to 25.912 meters. This is one of the values that they are going to mark on the previous question, in question number 1. And then we say 25.912 minus h, which is 5. It's going to give us 20.912, which we are going to come and put here. YB is 20.912 0.912 minus 216 squared. I'm going to erase this. And the answer that you are going to get here is 10.659 meters. And then we come back to this. Our total length of the cable will be 18.64 plus 10.659, giving us 29.299 meters. That is question number 2. We then go to question number 3. They say calculate the horizontal distance between the supports. First, let's write this value down. LB is equals to 10.659. Another value that we are going to need is YB. But you know it's going to be 20. Yeah, it's going to be 20 here because the difference is 5. So let's erase this. And we do question number 3. The distance between the cable is XA plus XB. Our XA is equals to YO ln in bracket YA plus LA all divided by YO. This is 18, then it's ln. YA is this 25.912 plus LA, we have it here, it's 18.64, and then this one is also 18. Then the answer here, I got that it is 14.174 meters. Then now we calculate for XB. YO ln YB plus LB YO. What is this? It's 18 ln LB is this one, and it is 20.912. Remember, we just minus 5 from this, plus LB is 10.659 divided by 18, and this gave me 12.763. So now we are just going to add this and this. Let me erase something here. The value of A, which is this, is 14.174 plus the value of XB is 12.763, and this is going to give us 26.937 meters. And this is how we go about answering this question. And that is going to be the end of our lesson. I will see you on the next lesson.